Hello, this is Corey with imod.systems. Today we have a copy of Pokémon Ruby that was sent to me for repair. A customer stated that when they inserted the game into their Game Boy, they were getting a scrambled Nintendo logo. So we're going to take a look at it and see if we can duplicate the issue and see if it's something that we can repair. So let's get it open. I haven't opened up the package yet, so just want to see what we're dealing with here. Right. Looks like the label is in relatively good condition. The cartridge itself looks legit, so we're off to a good start so far. Let's pop it into the Game Boy and see if we can duplicate what's going on. Yep. So you can see right away here that we have the scrambled logo, so there's definitely something going on with the cartridge. Let's get it open and take a look at it real fast. We've got our screwdriver with a Y bit here. Just gonna pop this open. It's not stripped, which is a good sign. Slide that off. And it looks like we have a botched battery replacement. It looks like that they were trying to remove the old battery. I don't know if you could see here. Let me zoom in real quick. Over here, grab my tweezers. Take a look at the RAM module here. These shorted pins. Let's see if we have anything else going on with it as well. Doesn't look like we have any broken traces. R9 here is usually a culprit for getting knocked off when people try to do a battery replacement. Thankfully, it doesn't look like they ripped up the pad here for the battery. The back of the cartridge just looks a little dirty. Yeah, just looks a little dirty, but it doesn't look terrible. So overall, I mean, this is in salvageable condition, which is nice. I think what happens a lot of time when people try to replace their batteries, I'm just gonna zoom in here and just show you. So I think a lot of times what people do, they try to work around their board. And I think that they end up getting their iron in the way. So we have a battery here. Just gonna, rest this here. And, for demonstration, I have my little J tip here just loose. And they try to heat the leg of the battery and the pad at the same time. And when they go to lift, when you're working around right here, you don't really have a lot of room. So, you have to heat the pad in order to lift the battery up. And it's just really easy to slide some, your iron over there and not even realize when you're focusing on lifting up the battery. When I replace these, what I do, I just like to turn the board. I'll turn it around this way. This way, I'm left-handed, so I come in here with my iron. And when I have to move my iron over to the pad, I have so much more room here. I just need to worry about this component right here, but I'm not gonna make contact with the RAM module. Another thing that I see happen a lot of times when people replace their batteries, they don't mask off the edge connector here, the cartridge pins. So when they lift the battery, it can get stuck, the solder will flick, or they're not paying attention. They rest the tip of their iron on the edge connector here, and then next thing you know, you get solder on your edge connector, and then pretty much the cartridge is toast at that point. The only way you can really repair it is if you send it out to a factory and get it replated. These are plated with hard gold for just corrosion resistance and also, just good contact. So you want to try to avoid that. So let's just get this masked off real quick. I think I could probably repair this fairly easy. I may not even need wick. I have wick on hand just in case if I do need it. But I'm pretty sure I could probably just flux it and maybe just work this off, but we'll find out in a moment. So let me grab some Kapton tape, get it masked off. It just takes an extra second. save you a headache, not having to worry about damaging your game. So let's get this. We got a lot longer piece than we'll actually need. Just toss that on there. There you go. Now we have peace of mind. We don't have to worry about permanently damaging this game. So I get my iron fired up. Got it on already. Get some flux on here. Now this is the first time that I'm actually working on camera, and I'm trying to make sure that this is in the shot and my head's not in the way and all that fun stuff. So what I'm doing first, I have my iron preheated to temperature. I'm using a Hakko FX 951, and personally I like the work hot. I keep my iron at 750 degrees Fahrenheit, which is hotter than what I would recommend a lot of beginners. I would probably recommend staying at like 600 to 650 if you're using like good leaded solder. I'm comfortable at this temperature. I'm comfortable using this station. I have experience with it, and you know, just what I'm used to working at. So that's where I keep my temperature at. So first thing I'm doing is just cleaning the tip of my iron. The solder is going to follow the heat. So if my iron tip is clean and I have flux down, I should just be able to wick up the solder here with the tip of my iron. Yep. I don't know if you could see that, but I already made a pretty good dent. So just cleaned it again. Just flow that. There we go, we have most of it up. Let's put my handle down real quick because I want to move my Game Boy because I didn't move it yet. It's making me nervous. Put down a little bit more fresh flux. Remember, flux is your friend. And the key here is just really making sure that you're keeping the tip of your iron clean, because like I said, the solder is going to follow the heat. And the heat is coming from my iron here. And it looks like I got most of it up. Just gonna finish it off with the wick. And when you're using wick, you are not using it as a scrubber. I'm just letting it rest gently on the component. And once again, we're gonna use heat and capillary action, and we're just gonna wick up the remaining solder. There we go. I think we just have one little tiny bridge left. Some more fresh flux on there. A little bit more wick. All right, I'm just gonna give it a look. Actually, let me clean it up first. So I'm just gonna get some 99.9% isopropyl alcohol on it. Looks like we still have a very, very small bridge there. I don't know if you can see it. Right over where that dot is. Right here. Looks like there's a small bridge. This is hard working around the camera because I don't want to get my head in the shot. Looks like it might be clear. Just gonna take a quick peek under my microscope. And sorry for that. I don't have a camera on my scope yet, so it is gonna be in frame. So just do it quickly. Yeah, we still have a small pesky bridge. And it looks like now that I'm seeing it, they may have tapped R7, the resistor as well. It doesn't look terrible. It just needs to be cleaned up with a little bit of flux and just a reflow. So let's get this back into frame. If I was working under my scope, I'd be able to clear this in a second, but my head is like a mile away. So I have the camera here. I'm just gonna do this under the scope. Oh, so, all right, so I have the short cleared. Like I said, it literally takes a second when you're working under a scope, but there is one other issue that I just found. So let me get this cleaned up and let me show you. So I don't know how well you can see this, but the pin here is actually shifted off of its pad. So basically what I'm gonna have to do, and I'm gonna have to do this under the microscope, I'm gonna have to heat the pin in the pad with my iron, and then I'll be able to use a tool, not my tweezers here, but I have like a microscopic probe, and I could gently just slide that pin over right back onto its pad. And then that should fix that up. So let me just grab my probe real quick. I'm really sorry that you're not going to be able to see this, but you should be able to see the final results. Hopefully one day soon I'll be able to get a scope for my camera and then you can see everything. It just makes working on this stuff so much easier when you can see it. You know. So I'm gonna slide this over. All right, so through the power of some movie magic, we are back. So this was actually a little bit more involved than I originally thought it was going to be. The leg of the chip was actually shifted over pretty good, and it was making contact with the other leg, and I was trying to heat it with my iron and just moving the leg over. It was not complying, so I actually had to switch over to my microscopic tip on my Hacko. And basically what I did, I was able to heat it, the individual pin, and while I was applying heat, I was able just to push it over back onto its pad there. So now it's making perfect contact again, and it's no longer shorting to its neighbor. So now we can get this cartridge cleaned up and we can test it out and see if we resolved our issue. So I'm just going to zoom back out. I'll just take you through my cleaning process real quick because we have it gummed up with some flux. So I'm just going to grab some Q-tips and we're just going to use some 99.9% ISO. We're just going to clean up the area here. While we're at it, I'm going to show you how I put the battery on. Yeah, we are pretty fluxy still. So I'm just going to give it a spray. Give it a good wipe down. Normally I wear gloves, but I didn't think to put gloves on. We can take the Kapton tape off of our edge connector. Give that a wipe down too. And this actually looks to be in really nice condition. There's very minimal wear. I'm not even getting any oxidation when I'm wiping it off with my wipe here. So you can see here, the short is now relieved. It looks decent in the area. I mean, if you look really hard with your eyes, you can tell there's been some rework there, but it's really hard to tell. It just needs to catch the light properly. So let's get it back over into the back half of our shell. We don't need the full shell. Pop this into our Game Boy and see if we work. Hey, look at that Nintendo logo. And we have Ruby. Yep, the internal battery is run dry. I wonder why. Rod, with a total time of 15 minutes played. Wow, okay. All right, well, it looks like we have a working game. So let's get a new battery in it and we can call it fixed. So again, let's clean this up real quick. Since we're going to be applying an iron to it and we're going to be using solder, remember, it takes an extra second. Put a piece of Kapton tape over the edge connector. So I'm going to grab a fresh piece. Pop that right there. Let's wrap that around. Cool. So let me change my iron tip back to my regular one because I'm not going to be able to deliver enough heat with the micro tip. Let's get this out of the way. It's my regular tip. Micro tip. Since we're hot, we're going to rest it on the mat. U-plug back in. Sorry for my rambling. I'm trying to do this as much unedited as possible. Like I said, it's unfortunate that I had to, cut and edit for the microscope work. I didn't want to bore you just staring into blank space. I'm hoping that I can get a nice microscope camera soon. Ooh, why are you beeping? Sorry about that. Just bad connection. I'm hoping that I can get a microscope camera and then I can show you that work because that's what I really enjoy doing. I really enjoy working under the scope. I really find it interesting and challenging, so I think it's more fun. Where is my wick? So I'm gonna wick up the remaining solder over here on the negative battery terminal. I'm just gonna grab my tweezers so I don't burn myself. Let's get up to temp. All right, we're there. So again, like I said, I'm not using this as a scrubber. I'm floating it. It's kind of a feeling thing. You'll get it with practice, but the reason why I'm not gonna let it scrub onto the board, because if I do that, you're gonna take off this green solder mask and it's just gonna look really bad and we're gonna have to clean that up. So I'm just resting it on top of the pad here, resting my tip on top of the wick. And then eventually, this is a ground plane, so it's gonna take a little bit more work for it to start flowing here. And they may have used lead-free solder because that's not flowing. So I'm just gonna grab some of my leaded 6337. Just flood in a little bit of fresh. There we go. See that? Nice formed pad now. And then I can just float my wick on there. And then I'm just floating it, but I'm feeding it. There we go. Just float it some more. Get a nice flat pad. There we go. That's not bad. Clean it up with some IPA. Looks like I have a little bit more there. Ooh, I got a little burr. Take that off. Let me clip this. Okay, let me rotate the board some. And I'm just resting it on here. It's okay. It's not gonna hurt anything. It's gonna require a little bit more heat because it's a ground plane. All right, we're nice and clean there. I'm just gonna touch up the positive pad. See if I can wake up anything else. I think we're as good as we can go there. All right, so let's grab a fresh battery. Get this installed. Let's get set up. Gonna put a fresh Panasonic battery in. Now the first thing that you're always gonna wanna do when you grab a battery, even if it's a brand new one, you're just gonna wanna test it for voltage, because you can get ones that are brand new that are dead on arrival. That's happened to me before. I actually have one on my bench right now that I have that I received that was brand new that's not working. And I'll show you just in a second. Let me grab my meter. So I'm gonna switch this over to DC voltage mode. And this is the battery I always keep on my bench that was received dead. It's just a reminder for me to always test it. So left side is gonna be positive, right side is gonna be ground. And look at that, I made myself look like a fool. That's not the battery. That's a good one that I had. Where is my bad one? Well, like I said, this is why you always test it. So that's 3.2 volts. That's actually good. 3.3. This is the one that I just pulled out. It's reading exactly the same, which is good. I may have chucked out the dead one, but anyway, it's always just a good rule of thumb just to test them out every time. I have been bitten by that. I've installed a battery thinking that it was good and it was dead. And that's frustrating. It's just a waste of time. So what I like to do with these, because if I sit it on top of the ROM chip here, it's not going to rest flush on the pads. You have to bend out this leg a little bit. So what I'll do, I'll just grab a pair of needle nose pliers. I'll support the positive side over here where it's been welded to the battery. I'll support that with my finger. Kind of just give it like a squeeze. And then I'll just bend this down like that. And then I'll bend it out. create like a little flat landing for it. There we go. So now that when we rest it, it's resting a little bit more flat. I can come down with it a little bit more. So once again, I'm going to support tab here. I could bend that out, make that flat. I don't want to put any pressure over here on the weld, because if I do that, I could break it off. Rest that. There we go. Much better. A little bit more room. Bend that one down and out. There we go. Now it's nice and flat. So what I like to do is I like to pre-tin the positive pad. So I'm just gonna wait for my iron to come up to temperature, because every time I put it in the holder, it goes to sleep. I'm gonna heat the pad. And like I said, I like to have the board rotated in this direction here, just so that when I work, you know, I'm not gonna make contact with this R9 resistor. I'm not gonna make contact with this component here that's a resistor. I'm not gonna make contact with the RAM module here. A lot of times, like I said, people will work on it like this, and there's so much more chance to hit stuff around there. So I'm gonna keep my board rotated. Let me zoom this in for you. There you go, get that frame. Heat the pad, and I'm gonna feed. There we go, nice little mound. Heat again, feed a little bit more. There we go, beautiful. And then I like to flux this. So I'm just gonna take my iron, I'm gonna dab it into the flux just for a second, tap it, get that wet. Get this all nice and fluxed up. It's gonna make it easier for me to work. Get this into place, just like this. Hold it down with my fingers, and then I can heat. The battery just sat down nice and beautifully. Look at that. Square on my ground as well. So I'm gonna rotate this again. I'm just making it into a position where I like it. I'm gonna heat the negative leg of the battery, and I'm gonna heat the pad at the same time with my knife tip. That's why I like using one of these. And then once I heat it, I'm gonna feed it. I don't wanna linger for too long. Go. Beautiful, we're done. So let's get it cleaned up. Let's grab my isopropyl alcohol. You always want to clean up your flux, even if it's no clean. Let's grab another one. All right, so we are good to go there. Let me zoom this back out. Actually, let me show you one last trick that I like to do with these games. So I always like, even though this game is in really good condition, I always like to clean it with some deoxit gold. This basically just conditions the cart connector and the pads there, just to make sure that it gets better contact with the game and we don't have any issues with it reading. So now, since we're not using the iron anymore, get this off, my Kapton tape. Get this seated here. So a little drop is all we need. Get a fresh Q-tip. Just give it a wipe down. Yeah, look how clean that is. Nothing came off. It's gorgeous. This game's in great condition. All right, let's get Tim back out. I'm just gonna give it one more quick wipe with IPA on the back side. Let this dry. Yep, yeah, we're no longer gummy. So pop this back in and see if we still get our battery message. Nintendo logo, we're still good. Hey, we didn't get a battery message, so we are good to go. So this is a relatively new save. If you had an older save, you would just need to reset your real-time clock. I'm not going to cover that in this video. There's other tutorials out there. There's a number of different ways that you can do it. You can use PK Hex, you can use a modded DS Lite, or you could just start a new game, which I'm going to do here. And when I start the new game, I'm just going to set the clock. So anyway, I hope you enjoyed this video. Thank you very much. This is my first upload to YouTube, so I know it's going to be pretty rough. And sorry for the rambling and not being able to show you what was happening under the microscope, but hope you still learned something on how to repair this. Like I said, it was really straightforward. It just took a little bit of skill and the proper tools, and we were able to get it up and running. And this is a really good condition game, and get this returned back to its customer. So thank you very much.